Okay, a very good afternoon to everyone. Thank you so much for having me, and it is great to be talking about the space sustainability because it's so important, and it's specifically important in the coming days, mainly because there are thousands of satellites that are planned to be launched in the next 5 to 10 years. And we want to make sure that the orbits in the space around us is safe and also sustainable for the future missions to come. So basically, we have heard a lot of these great messages and initiatives from senior leaders, politicians, and even royal family in the last week's Space Sustainability Summit, where His Royal Highness, the Prince of Wales, spoke about the importance of keeping space sustainable. And also we heard from Science Minister George Freeman, who announced new initiatives and new measures and investments in space debris removal. What I would like to highlight here is it is not just up to the leaders or politicians. It is each and every individual in this room who have got great scientists and engineers working in space industry. So that's mainly because highlighting one of the quotes from Robert Swan, who is the environmental leader, the greatest threat to our planet, and this definitely applies to space, is the belief that someone else will save it. So this is to say that no, we all need to take our initiative and do our part in order to make space sustainable. So before I go into the details or talk more about sustainability, I just wanted to give a quick overview on who we are and what we do. So UK Space Agency is an executive agency within a Department of Business, Energy and Industrial Strategy. We were founded in 2010. And we are led by Paul Bate, who is our current CEO, who joined the agency in September last year. We have got around 350 staff across 3 different locations, Harwell, London and Swindon. And our core value propositions are mainly to catalyze investment by supporting projects that multiply private capital and contracts for the UK space sector, deliver space capabilities and missions, and also champion the power of space to inspire, to offer greener, smarter solutions for other industries, and to support our sustainable future, which is what I'm going to address today. So Office of Chief Engineer is a new team which was established only in March last year. This is to act as a competent and agile technical team to support the delivery of projects and programs across the space agency. So we have got our CEO Paul, and we have our deputy CEO is Ian, and also different directorates here. But we sit here, we directly report to Ian, and we work across various projects across all different directorates. Our activities vary a lot, so we provide technical insight, assessment and assurance capabilities to the UK Space Agency. The team acts as a principal advisor to the Space Agency and to other senior officers across government on areas related to the technical and programmatic readiness and execution of the UK space activities. So this again mirrors the capabilities that other organizations have, like for example, ESA has their technical offices, NASA has the Office of Chief Engineer as well, and also JPL has TMAX. So we within Office of Chief Engineer have 4 different streams: space, payload, launch, and mission. I lead one of them, that is the payload. And our responsibility is mainly in our own areas, looking at the design and development activities, the new technologies that are coming up, and also performing mission analysis. So that's who we are and what we do. Coming back to the sustainability. So why this is so important. I'm sure you all have heard different versions of this, but I still would like to highlight that's because it's so important, and we need to understand the seriousness of the problem. So 73% of the tracked debris in low Earth orbit alone is mainly made of the non-functional human-made material in orbit caused either by from the boosters of launch vehicle stages and also the satellite collisions and explosions. 21,000 objects, which are larger than 4 inches in diameter, are tracked by US Space Surveillance Network. There are around 500,000 objects which are larger than 1 centimeter in diameter or the size of a marble. And there are another tens of millions of paint chips-like pieces that measure less than a centimeter. And why is this a problem? Just to give you a relative measure, so let's say the speed of, we all know the speed of sound is around 768 miles per hour. An average bullet travels around 1,700 miles per hour. So we can't imagine somebody shooting our satellites in a gun. But imagine all these debris are traveling 10 times faster, that is around 18,000 miles per hour. And to add to this, there are some of the planned or unplanned collisions in space. So we had China's anti-satellite mission in 2007, and also there was the first major impact between the Iridium-33 and also the Cosmos. This is in 2009. These two alone created 60%, more than 60% of the debris in low Earth orbit. So this could lead to loss of mission or reduction in performance. For example, the picture here in the top center shows it's from Sentinel-1A, the solar array before and after the impact of a millimeter-sized particle. And the one here is the impact that penetrated the satellite dish of Hubble telescope. And it is also a risk on the ground. We find a lot of these different rocket stages. This is in Brazil, Spain, and Indonesia, which are, again, dangerous to the mankind. There are a lot of initiatives taken internationally. So the United Nations Committee on the Peaceful Use of Outer Space defines space sustainability as the ability to maintain the conduct of space activities indefinitely into the future in a manner that realizes the objectives of equitable access to the benefits of the exploration and also our use of outer space for peaceful purposes. Both this is to meet the needs of the present generation while preserving the outer space environment for future generations, which is very, very important. And we could do this using 4 different levers. One is the national regulation and best practices. In the UK, we have got CAA looking after that. And we could have the mitigation, that is not to create new debris by following good mission designs and satellite designs, and also doing some on-orbit servicing and preventing the predictable collisions, both at launch and also the satellite collisions that we spoke about a minute ago, and remediation, that is removal of massive debris. Coming to the mitigation, so we have got IADC, so the Interagency Space Debris Coordination Committee, which has defined the protected regions. So in lower Earth orbit, we have a spherical region that extends from the Earth's surface to an altitude of 2,000 kilometers. And also in geosynchronous region, we have a segment which is 200 kilometers above and below the geostationary orbit. So here for LEO, we have got guidelines such as spacecraft to be removed from the orbit region after 25 years. We could do that by implementing drag sails, electrodynamic tethers, and also propulsion. Yes, it does have an impact that we may limit the altitude of operation and also requires additional subsystems, but we are contributing towards sustainability here. And the second one could be the disposal reliability threshold, that is to select components which offer high reliability in order to avoid single point failures. The impact could be it will drive the component selection. Of course, the cost might go a little bit higher, and also we need to take into account the design for the architecture and the mission life as well. Trackability, which is again to ensure spacecraft can be tracked by the space surveillance network that helps us to understand and mitigate against these collisions. So this is in LEO. Coming to GEO, again, all these LEO guidelines apply here, but also in GEO, the guideline is to terminate the spacecraft away from, so once the spacecraft is finished its operation, to move away from the GEOs so that it does not interfere with other satellites, that is moving them into graveyard orbits. Next is the collision avoidance. The US force uses the space surveillance network to track the largest objects. Again, they do have a worldwide network on ground, which are ground-based radars and optical telescopes worldwide. They track objects approximately 10 centimeter and larger in LEO and 1 meter and larger in GEO. They share this data worldwide, and through the space sharing agreements and also spacetrack.org. So the pictures here highlight the importance of them being trackable. So the one above is the NVSAT, and the bottom is the light trace from satellite overheads. So the objects need to be of a certain size to perform collision avoidance. And the current conjunction assessments and collision avoidance maneuvers against the tracked objects only address a small fraction, that is less than 1%. So coming to the remediation, that is a removal of massive debris. So this is a projection of the low Earth orbit environment obtained with the NASA's orbital debris evolution model legend. Here, what we have is the red chart, the red line here showing the following the complying with the space debris mitigation guidelines, along with 90% of PMD. PMD is post-mission disposal. So this improves or prevents the increase of debris. But in order to keep it sustainable or at the level that we have now, we need even better, which is we need to comply with the space debris mitigation guidelines and then have 90% of post-mission disposal. Along with that, we need active debris removal. So if we waited till 2060 and removed like 4 debris per year, this is the trend we would follow, that is the blue line. And if we were to be in the green line, we need to start that now. Like since 2020, we should have been removing 5 satellites or 5 debris, sorry, per year. So UK is playing a major role in debris removal. So the objective here is mainly to remove actively the targets from orbit. So these targets could be the satellites or the debris that have high probability of collision, and the rocket bodies. And the concept of operation would be we would launch active debris removal satellite, rendezvous with the threat or the target, and then capture it either by cooperative methods or uncooperative methods, and then dispose them. The technologies needed here are LiDARs, camera, targeting systems, and also to capture, we need robotic arm, harpoons, and nets. And there are already a couple of missions. One is the remote debris, which we are all aware of, and also ED orbit. So here we have a remote debris, which is the largest satellite to have ever been deployed from International Space Station, which was launched in 2018. The platform contained 2 CubeSat deployers from ISS Space, and also there was a large involvement from Surrey Space Center, and the system was integrated in SSTL. These harpooner that you can see, the subsystem was provided by Airbus. So this one, rather than engaging in the active debris removal of real space debris, the remote debris mission plan was to test several technologies that I mentioned earlier in low Earth orbit. So in order to complete its planned activities, it was equipped with a net, a harpoon, a laser ranging instrument, a drag sail, and also 2 CubeSats. The next one was, I just wanted to briefly touch on net zero. Although we are starting to look at this, the policy and the regulations are not as progressed or advanced as the sustainability side. But we do have a national space strategy, which is focusing on missions like Truth, which could establish the world's first climate and calibration laboratory in space, and also lay the foundation for leadership in emerging markets that have the potential to disrupt industries, including in the highly important area of clean growth. One is the space-based solar power. Again, I lead this study within the agency. So there was a lot of initiative last year from BASE, who conduct an independent study, which was led by Fraser Nash, and which concluded that there are not any fundamental technical barriers. So we do know how to build photovoltaic cells, we do know how to build satellites and launch them. But the issue there is programmatics and the economic side of things, bringing the cost down, and for which we need to have other enabling systems like in orbit servicing and manufacturing, and the low cost for the launches, etc. So that's what we are focusing on now. And there are a couple of other grant calls which are planned this year that might be out soon. Again, this will be both UKSA and BASE joint calls. I wanted to highlight some of the key roles that UK is part of. So we have invested in our national space surveillance and tracking capabilities to reduce the risk of collision. In 2021, we announced 1 million of grant funding for 3 space companies, SSTL, Astroscale, and ClearSpace. So that completed phase 0 Hey law, I think early this year, and now they've entered phase B. So UK plays a significant role in international efforts to promote sustainability that includes G7 to strengthen our collective efforts. In 2021, the UK Space Agency awarded 1.7 million in funding through the National Space Technology Programme to 13 pioneering projects to develop technologies such as new sensor technology or artificial intelligence and such. And UK is one of the largest investors in the ESA's space safety program. This includes 20 million for space sustainability in 2019. So we're doing a lot of great work, but we're not there yet. So that would be my key message here. Thank you.
Thank you for that really good introduction to the subject, and it's really interesting to hear, particularly, I guess, what the UK's angle is on this and where it sees itself growing. And I know that the recent summit was very much about the UK's leadership in this area. So I think that's a really important message to take away is, you know, we've all got a part to play, as you said at the beginning of your talk, and hopefully that's what we're promoting here today. So thank you very much again for your talk there.
Thank you so much. Thanks, Chris.